Hi, welcome to Hydraulics and Hydrology, ETC 2521. My name is Sandra Bowling and I will be your instructor this semester. So let's get started. The topics that we're going to cover this semester include hydrologic and hydraulic analysis, stormwater management designs, storm drain designs, open channel flow, culvert designs, permitting with the agencies, and we'll be working on a couple projects and case studies. The first topic we'll cover is hydrologic and hydraulic analysis. Now, the class is hydraulic and hydrology, but we're going to look at hydrology first. So what we're going to look at in this session is the purpose of hydrology and the purpose of hydraulics with respect to land development. Now, when we're talking about hydrology, we're actually talking about the quantity of water that comes down and where it goes. The hydraulics is once that water gets to the ground and wherever it goes, we have to size some type of structure either to hold the water, such as this pond here, or you can see a culvert here to size that culvert to pass the water through. Even in this pond, you can see way back here, there's actually a storm structure. When we're talking about sizing something for the amount of water coming through, we're talking about the hydraulics of the movement of water, whereas the hydrology is telling us how much water is actually coming down in the form of rain or some type of precipitation. When we're talking about stormwater practices, we're talking about flood control, looking at water resources, irrigation, water quality, making sure there's no pollutants or anything degrading our natural resources, and stormwater management in general requires the engineers to have a certain standard of practices based on regulatory policies. Now, flood control sounds like what it means. It means if you have a pond or there's a lake or a stream that's adjacent to some type of property, we don't want that property to flood based on certain storm events. Water resources, when we're talking about water supply, irrigation, or hydroelectric power, all of the water that is supplied to us comes from either the aquifers, or for irrigation they might be storm ponds or some type of farm ponds. And when we're, like I said, when we're talking about water quality, we're talking about using ponds to remove pollutants before they get into our actual natural waters or our streams. And like I said, water management practices or management in general is we have some type of regulatory agency that says we have to meet certain standards based on water quality and water quantity. So who are those agencies that I'm talking about? We've got local, so we got city, we got county. All those agencies have some type of design standard. We also have state agencies such as the Environmental Protection Agency, the Department of Transportation, water management districts. In the state of Florida, we have several water management districts. We have the St. Johns River Water Management District, Southwest Florida, South Florida, just to name a few. We also are talking about the NRCS, the Natural Resource Conservation Service, which was originally the SCS. So you'll hear some people call it still the SCS, depending on how old they are. And we've got the federal. So we've also got the Environmental Protection Agency on like almost a federal level. And we also have one other one that I didn't list, and that's the Army Corps of Engineers. They usually look at our wetlands. All right. Now, since we've talked about our agencies, when we submit to agencies our construction plans and our drainage documents, we're actually going to be sending them our calculations and computations. Now, there's a little bit of difference between a calculation and a computation. So the computation is just the numbers. Now, the calculations, let's pretend that they're the overall presentation of the documents. So if you're trying to explain something to somebody and you're doing it in mathematical terms, you want it to be presented in the best light possible where it's easy for the reviewer to understand. So just keep that in mind when you're doing your calculations. Now, here's the steps that we're going to be looking at this semester to design a stormwater management pond. First, we're going to have to delineate a watershed. That means how much water is going to a certain point on the drainage basin. And then we'll collect data on the correct characteristics of what a watershed is. Those characteristics include time of concentration, curve numbers, and we'll go over those later in the semester in the next presentation, sorry. We'll also talk about design storms. What does it mean by a design storm? Is it a hurricane event, a 100-year event, a 10-year, 72? So when I say these types of numbers, I'm talking about the design storm. All of the agencies have a design storm event that you have to design too. So we have to take a look at those. We're also talking about excess precipitation. When somebody says it's excess precipitation, they're actually talking about runoff. How much water actually runs off. So imagine a Home Depot parking lot versus this field back here. What's the difference? Home Depot parking lot has asphalt all over the place where the field is mostly grass. So which is going to have more runoff? Home Depot's parking lot or the field that has grass in it? Runoff being that water just slides right over the top of it. You can think of it like that for right now. We also have to determine peak flow. That means how much water at a certain rate flows overland into or out of an area. And then we're going to have to size that structure. For example, this pipe down here or that control structure in the back of the pond. We have to design the hydraulics of all of those structures. So we'll be going over each one of those in its own mini lecture this semester. When we're talking about the storm facilities designs outcomes, we're talking about both the pond and the storm structure. We need to make sure that it performs as required by all the rules and regulations that's been put on it. We also have to make sure that it's constructed under a certain budget and it's maintained easily. We can't allow our structure or the pond itself interfere with the utilities such as water or sewer. It needs to be constructed in a safe manner and it has to last a certain lifetime. Now we also have to make sure that it does not present a safety hazard or unduly degrade the natural environment. And lastly, it needs to be aesthetically pleasing. I'm going to pause here and we'll recap. The hydrologic and hydraulic analysis that we just talked about is we looked at water as it came down in the form of precipitation. Once we figure out the hydrology of that, we have to look at the hydraulics of it. That means how are we going to deal with it when it gets into our ponds, our stormwater management facilities? How are we going to size the structure? In this next little session, I'm going to go over our resources of where we can find hydrologic and hydraulic data to compute all of these calculations that we'll need for our designs.